For decades, scientists have advanced the evolutionary theory of origins. Of an Earth that formed by slow cooling of molten mass over 4.5 billion years to make the foundation rocks of the continents, the granites. Of life that began spontaneously in some primeval sea and then evolved over hundreds of millions of years to produce the many life forms we see on the Earth today. Of the eons-long formation and drying up of these primeval seas to produce sedimentary rocks such as in the Grand Canyon, with the canyon itself carved by the Colorado River over millions of years. Of coal and oil deposits, buried in sedimentary rocks around the world, which presumably required millions upon millions of years to form from the accumulation and decomposition of vegetation existing in ages past. But have scientists considered all the evidence in arriving at their theory of an anciently evolving Earth? What if there was evidence in the granites themselves that showed they formed rapidly instead of by slow cooling? What if there was evidence that these sedimentary formations composing the Grand Canyon were deposited quickly instead of slowly? What if there was evidence the canyon itself was carved over a short time by rapid erosional processes? What if there was evidence revealing that coal and oil can form rapidly and did so recently? What if there was evidence that dinosaurs existed not millions of years ago, but just a few thousand years ago? And what if it was found that natural laws, the glue which holds the evolutionary framework together, cannot explain everything in Earth history? We would then be forced to consider another model of Earth history, one that would acknowledge the possibility that geological rates of change in the past were much greater than those observed today. In this scenario, it would take much less time for various geological events to occur. We would then have all the ingredients for concluding that the Earth is actually quite young. But is there any published scientific evidence which challenges the evolutionary view of an ancient Earth and supports a young Earth? Scientist Dr. Robert Gentry, while working at the Oak Ridge National Laboratory in Tennessee, has found just that, publishing evidence which challenges the long time period of Earth's history. In 1977, the Research Communications Network published a special breakthrough report on the results of Dr. Gentry's scientific publications, characterizing their implications as follows. Current physical laws may not have governed the past. Earth's primordial crustal rocks, rather than cooling and solidifying over millions of years, crystallized almost instantaneously. Some geological formations thought to be 100 million years old are in reality only several thousand years old. Grant these propositions and any researcher will tell you the entire structure of the historical natural sciences would dissolve into formlessness. Few certainties would remain. Yet these very possibilities, and others equally challenging, have been suggested in a remarkable series of papers published over the past several years in the world's foremost scientific journals, Nature, Science, and Annual Review of Nuclear Science, among others. From Research Communications Network, Breakthrough Report 1977. Part of Dr. Gentry's work referred to in this quote pertained to his work with coalified wood from what is known as the Colorado Plateau, a broad geographical region encompassing parts of Colorado, Utah, Arizona, and New Mexico. Using the microscope and more advanced laboratory equipment, he analyzed these specimens of coalified wood for various types of radioactivity. His results help us to understand how long it takes coal to form, the age of the coal, and the age of the Earth itself.
What are Earth's vast energy resources? Before we can answer the question as to the age of coal and the time of its formation, we need to ask the question, where did coal come from? Here in this coal mine in Price, Utah, we have the answer. Here is a log, almost completely turned to coal. There are thousands of such logs in this mine and in other mines here in the Price area. This fact tells us that given the right conditions of pressure and temperature and water and time, that wood and other vegetation will turn to coal. The question is, how long did it take for that to happen?
Robert Gentry and his son David, an associate in his father's work, explore this topic together.
To answer this question, we need to look at coalified wood specimens from uranium mines instead of coalified wood, like this log, from one of the coal mines here in the Price, Utah area. This coalified wood specimen comes from La Salle, Utah, a uranium mine. Its presumed geologic age is around 140 million years.
This specimen of coalified wood comes from a uranium mine in the Temple Mountain area here in Utah. Its presumed age is also 140 million years. But look how closely this specimen resembles this other piece of wood. They're nearly identical. It's interesting to note that this other piece of wood was derived from a fresh piece of wood like this, just a few weeks ago.
This close similarity raises an important question. Is it really true that this piece of coalified wood from La Salle, Utah, and this piece of coalified wood from Temple Mountain, Utah, are really 140 million years older than this piece of wood which David and I recently obtained in some of our experiments? Not really. Locked in these and other coalified wood specimens from uranium mines is some remarkable evidence that tells quite a different story. To see that evidence requires that the coalified wood specimens be mounted in epoxy, thinly sliced, and then placed on glass slides for observation under the microscope. Under the microscope can be seen discolorations produced by radioactive particles ejected from tiny centers. Some are circular, others are elliptical, as can be seen in these photographs. These circular and elliptical halos required a special sequence of events to form, so special, in fact, that they completely overthrow the idea of an ancient age of coal, pointing instead to coal's recent formation, geologically speaking. To explain the halos requires that at one time, water-saturated logs were buried in what are now considered to be several different geologic formations: the Eocene, Jurassic, and Triassic. Later, uranium solutions infiltrated those water-saturated logs, and uranium decay products, radioactivity, was collected at tiny sites in each of those logs. That radioactivity decayed over the next several months to a half year, ejecting particles and producing spherical radiation-damaged regions, halos around those tiny sites. In cross-section, they appear to be circular. They were formed by the decay of secondary polonium, derived from the decay of uranium. Then there was a compression event. Something applied pressure to the top of all these formations. The logs were compressed, and when the logs were compressed, the halos were compressed. This brings us to an important point. We know that these logs had not turned to coal at the time the compression occurred. Here's a piece of coal. Coal doesn't compress. It shatters, as we can easily see. All the information we've seen thus far would indicate that these events were simultaneous in all these geologic formations. But there is even more evidence of that. When uranium invaded the wood, it left some of its decay product since the time that it invaded the wood. I measured both the amount of uranium in these coalified logs and also the amount of lead, the decay product. On the assumption that the decay of uranium to lead has been uniform, it's an assumption we'll discuss later, we arrive at the conclusion that all these logs were buried together quite recently. How recently? In 1976, I published my results of the studies on these logs in the October 15, 1976 issue of Science. Here's what I said in this report. Such extraordinary values, referring to these lead-uranium ratios, admit the possibility that both the initial uranium infiltration and coalification could possibly have occurred within the past several thousand years. In other words, I was suggesting that coal could form very rapidly, geologically speaking. It contradicted the conventional way in which people have thought about the formation of coal. What was the reaction of the scientific community to this new data? I received a letter from Professor Raphael Kazman of Louisiana State University several months later, January 27, 1977. Dear Dr. Gentry, I have been patiently scanning the letters section of Science since the publication by you and your colleagues of your findings on radio halos. The silence is deafening. I think it can be interpreted as stunned silence. Your results will not greatly trouble the engineer, but the impact on the science of geology in possibly changing the accepted views as to the duration of geologic time will be felt for many years. Very truly yours, Raphael Kazman. Soon thereafter, Professor Kazman organized a symposium. It was entitled, It's About Time, 4.5 billion years. Is the Earth really 4.5 billion years old? When the results of the symposium were written up and published in the September 1978 issue of GeoTimes, here's what was said. However, since the deposits from which the coalified wood was obtained are considered to be at least of Cretaceous age and possibly of Jurassic or Triassic age, the ratio between uranium-238 and lead-206 should be low. Instead, some such halos have been found with uranium-lead ratios ranging from about 2,200 to over 64,000. If isotope ratios are to be used as a basis for geologic dating, then presently accepted ages may be too high by a factor of 10,000, admitting the possibility that the ages of the formation are to be measured in millennia. Translated, that means several thousand years for the formation of coal and all of those geologic formations. This information has remained unchallenged and unrefuted in the open scientific literature since it was published in 1976. We are therefore entitled to draw some rather firm conclusions about the data. Geologists have assumed the Eocene was about 60 million years ago, the Cretaceous about 110 million years ago, the Jurassic 160 million years ago, and the Triassic 225 million years ago. But the results that we presented contradict that information. It's showing instead the simultaneous burial of all these formations about several thousand years ago. These results pertain to the origin and age of coal wherever it is found.
But if coal did not form slowly, is there any laboratory evidence showing that it can? In this demonstration, Robert and David Gentry begin to answer this question.
Earlier we took a piece of wood like this, inserted it in this steel pipe, added some water, and then sealed it up. The next step is to put it in the oven at about 160 degrees centigrade for 2 weeks. Now we're ready to examine the results of this experiment.
As we can see, this wood is now darker in color. It's also softer. A chemical reaction between the steam and the wood under pressure has caused these changes to occur. This specimen isn't coal yet, but clearly the process of coalification has begun.
The question is, would coal result if this experiment, or a variation of it, continued for a longer period of time?
Scientists at Argonne National Laboratory have answered this question in a series of experiments performed in the 1980s. One of the earliest reports about their work appeared in the magazine Chemical and Engineering News in the November 21, 1983 issue. On page 42 of this issue, we read the following quote: "Chemists at Argonne National Laboratory have succeeded in making a type of artificial coal from naturally occurring materials. The process is much less severe than formerly thought to be necessary and provides some new insights into coal structure and how to alter it." Later, after their published reports appeared in the science journal Organic Geochemistry, the British science journal Nature reported on the success of their experiments. On page 316 of the journal Nature, March 28, 1985, we read the following: "Winans and his colleagues at Argonne National Laboratory have taken less than 1 year to prepare a thoroughly characterized synthetic coal. The material they produce is indistinguishable from the real thing by all the techniques so far applied to it, and its synthesis raises many interesting questions in coal chemistry.